Alright, dude, let's go. Number 10. Interstellar Objects. In 2017, astronomer Robert Warwick of the University of Hawaii Institute for Astronomy was processing images from the Pan-STARRS 1 telescope when he identified an object moving through the solar system on a trajectory that could not have originated here. The International Astronomical Union's Minor Planet Center confirmed it as 1I/ʻOumuamua, the first known interstellar object ever observed passing through our solar system. But here's where the unease begins. ʻOumuamua did not come from anywhere in our system. Its path traced back to interstellar space, suggesting a journey lasting millions, possibly billions of years before any sunlight from our star ever touched its surface. What unsettled astronomers most was not the object itself. It was the realization that followed. If one interstellar visitor had been detected, others had almost certainly passed through unnoticed. The solar system is not a closed system. It is a place that receives travelers from the wider galaxy, quietly, without announcement. Most would leave no record at all, only a faint reflection of light that had begun traveling long before we existed. The solar system may be visited far more often than we realize. Number 9. The Boötes Void. In 1981, astronomer Robert Kirshner of the Harvard-Smithsonian Center for Astrophysics was conducting galaxy redshift surveys when his team mapped a region of space in the direction of the constellation Boötes and found something that contradicted everything cosmological models predicted. The disturbing part isn't that this region exists, it's what its existence implies. The Boötes Void spans roughly 330 million light-years across. In a region that size, standard models of cosmic structure predict the presence of thousands of galaxies. Kirshner's survey found only a handful. The void is not a gap between galaxy clusters in the way astronomers expected voids to appear. It is an absence on a scale that sits at the outer edge of what current cosmology can comfortably explain. Researchers have proposed that it may be the result of smaller voids merging over billions of years, but no consensus has fully resolved why this particular region is so profoundly empty. The galaxies surrounding it reveal its edges through light that began its journey long before we existed, light that has been traveling across that emptiness the entire time. In a universe filled with galaxies, one region appears almost completely abandoned. Number 8. Gamma-ray bursts. In 1997, the Bepo-Sac satellite, operated jointly by the Italian Space Agency and the Netherlands Agency for Aerospace Programs, detected the first optical afterglow of a gamma-ray burst. Astronomer Jan van Paradijs of the University of Amsterdam used that afterglow to trace the explosion to a distant galaxy, confirming for the first time that gamma-ray bursts were not local phenomena, but cosmological events occurring across the universe. What makes this phenomenon especially unsettling is its scale. Gamma-ray bursts release more energy in seconds than the sun will produce across its entire 10 billion year lifetime. They are the most energetic explosions observed in the universe since the Big Bang. If one occurred within a few thousand light years of Earth and its jet was pointed in our direction, the resulting radiation could strip away the ozone layer within hours. Ultraviolet radiation would then reach the surface at levels lethal to most complex life. There would be no warning system capable of responding in time. The burst would arrive as radiation and light that had been traveling toward us since long before we existed, and it would arrive at the speed of light. In space, extinction can travel at the speed of light. Number 7. Magnetars. In 1998, astrophysicists Robert Duncan of the University of Texas and Christopher Thompson of the Canadian Institute for Theoretical Astrophysics published their theoretical framework describing a class of neutron stars with magnetic fields trillions of times stronger than Earth's. They called them Magnetars, and the name has not been contested. The truly terrifying aspect isn't the star itself. Magnetars produce the strongest magnetic fields known to exist anywhere in the universe. Those fields are not passive. They are actively destructive at distances that would seem safe from any other stellar object. The magnetic force from a magnetar is strong enough to distort the electron clouds surrounding atoms, fundamentally altering the structure of matter itself. On December 27, 2004, a magnetar designated SGR 1806-20 released a flare so powerful that it measurably ionized the upper layers of Earth's atmosphere from a distance of roughly 50,000 light-years. Instruments across the planet registered the pulse. It arrived as a burst of radiation and ancient light that had left the explosion long before any living person now on Earth had been born. Some stars are powerful enough to reshape matter itself. Number 6, the Great Attractor. In 1986, astronomer Alan Dressler, Sandra Faber, and their collaborators, a group that came to be known informally as the Seven Samurai, identified something anomalous in the motion of galaxies across a wide region of sky. Thousands of galaxies, including the Milky Way, were moving toward a specific region near the Centaurus cluster at roughly 600 kilometers per second. The source of that gravitational pull became known as the Great Attractor. What makes this discovery unsettling is that we cannot see it directly. The zone of avoidance, the dense plane of dust and gas running through the center of our own galaxy, blocks direct observation of the region where the Great Attractor lies. Astronomers cannot simply point a telescope at it. Its presence is inferred entirely through the motion of the galaxies around it, including our own. Estimates suggest a mass on the order of 100,000 billion suns concentrated in a region of space still not fully mapped. Its structure will only become visible through light that began traveling toward us long before we existed, and we are already moving toward it. Something enormous is pulling galaxies across the universe. Number 5, the Fermi Paradox. In the summer of 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when, during a conversation about recent reports of unidentified aerial phenomena, he asked a question that has not been answered in the 7 decades since. The question was simple. Where is everybody? The unsettling interpretation isn't that aliens are rare. The Milky Way contains an estimated 200 to 400 billion stars. Conservative estimates suggest billions of those stars host planets in habitable zones. A technological civilization with access to even modest interstellar travel could, according to calculations, spread across the entire galaxy within a few million years, a time span that is geologically brief. SETI researchers have been conducting systematic radio surveys since 1960. No confirmed signal of extraterrestrial technological origin has ever been detected. The silence is not for lack of looking. Some researchers, including Robin Hanson, have proposed that the silence reflects the existence of a great filter, a barrier, biological or civilizational, that most species never survive. If that filter lies ahead of us rather than behind us, the absence of signals is not reassuring. It is a data point. Silence, in a universe this large, is its own kind of message. Number 4, dark flow. In 2008, Alexander Kashlinsky of NASA's Goddard Space Flight Center published an analysis of data from the Wilkinson Microwave Anisotropy Probe, WMAP, in which he described an anomalous motion in the cosmic microwave background. Hundreds of galaxy clusters across distances of billions of light years appeared to be drifting coherently in the same direction. But the implication nobody wants to say out loud is this. The motion Kashlinsky identified, which his team termed dark flow, could not be fully explained by any known gravitational structure within the observable universe. The pull did not trace back to any visible supercluster or concentration of matter that astronomers could account for. One hypothesis, consistent with some models of inflation, is that the source of the attraction lies beyond the boundary of what we can observe. A region of the universe that existed before the light we can detect had time to reach us. The evidence for dark flow appears not in direct observation, but in faint distortions, embedded in ancient cosmic light that began traveling long before we existed. The debate over its validity continues, but the hypothesis it opened has not been closed. Something outside the observable universe may be influencing ours. Number 3, heat death of the universe. The thermodynamic fate of the universe was not proposed by a single researcher in a single paper. It emerges from the second law of thermodynamics, formalized by Rudolf Clausius in the 19th century, and extended across cosmological timescales by generations of physicists since. The conclusion those calculations produce has not changed. The real horror isn't destruction, it's the absence of it. Over timescales measured in trillions of years, the stars exhaust their fuel and go dark. New star formation slows as the raw material available for it disperses. Black holes, the last gravitationally dominant structures in the universe, gradually lose mass through a process Stephen Hawking described in 1974. Quantum mechanical emission at the event horizon, so slow it operates across timescales that dwarf the current age of the universe many times over. Eventually, even the black holes are gone. Energy spreads evenly through space until no concentration of it remains large enough to do work. No heat differential exists. No process can begin. The final photons drifting through that space will be light that began traveling long before we existed, and they will travel forever, finding nothing. Eventually, the universe becomes a place where nothing ever happens again. Number 2, false vacuum decay. In 1977, physicist Sidney Coleman of Harvard University published theoretical work exploring the stability of the quantum vacuum, the baseline energy state of the universe. The mathematics he developed raised a possibility that has been discussed in theoretical physics ever since, without resolution. The implication physicists rarely say aloud is this: the universe may not exist in its lowest possible energy state. It may instead occupy what physicists call a metastable false vacuum, a configuration that is stable enough to persist, but not the configuration with the least possible energy. If that is the case, a sufficiently energetic quantum fluctuation anywhere in the universe could trigger a transition to a lower energy true vacuum. The resulting bubble of altered spacetime would expand outward in all directions at the speed of light. Inside that bubble, the fundamental constants of physics, the values that determine the behavior of matter, energy, and force, would be different. Atoms, as they currently exist, would not be stable. The process would be irreversible, and it would be invisible in advance. You would never see it coming. The signal would arrive only as light from an event that began long before we existed. The laws of physics themselves may not be permanent. Number 1, the cosmic microwave background. In 1965, Arno Penzias and Robert Wilson of Bell Laboratories were calibrating the Holmdel Horn antenna in New Jersey when they detected a persistent low-level noise arriving uniformly from every direction in the sky. After ruling out interference from the antenna itself, including famously pigeons nesting in the receiver, they confirmed what they were detecting was real. It was later identified as the cosmic microwave background radiation, the oldest light in the observable universe. The unsettling truth hidden in this signal is easy to overlook. The cosmic microwave background is not a historical artifact stored somewhere in space. It is radiation still traveling, still arriving, still present in every direction. Any instrument on Earth points toward the sky. It was released approximately 380,000 years after the Big Bang, when the universe cooled enough for electrons and protons to form neutral hydrogen and space became transparent for the first time. That light has been traveling ever since. Every radio telescope that detects it is not looking at a record of the past. It is receiving light that is still in transit, light that began its journey billions of years before Earth formed, before the sun ignited, before any of the matter that makes up every living thing on this planet had assembled into anything at all. It has been crossing the universe the entire time we have existed, and it was crossing the universe long before we did. The universe is still sending us light from a time before our planet was born. If you want to see more videos like this, click the video on screen now and make sure to subscribe.